Okay, and we're back. All right, so now what we're going to get into is some fun stuff, right? So now some stuff that you are going to be able to use even more of this new tool stuff for your assignment, right? So now we're going to pass arrays to methods. And this becomes really important stuff, right? Because before we talked about how when we pass something to a method, we couldn't change its value, right? We did the swap method and it didn't swap the value like we expected. But with arrays, we can change the values inside of arrays, and you'll see why in just a moment. So basically, an array becomes just like any other variable that we pass to a method. We take this, the name of this array is a list. We can put the list variable there, not with the brackets. Make sure you don't include the brackets, okay? Because you're not passing a specific value, you're wanting to pass the whole thing, okay? The whole array. Now, it will take this array, it will put it into this array variable here, and then it will do whatever this method is supposed to do. We can also do this using what's called an anonymous array, where if we don't want to create a new array, but we don't want to create a new array variable like this, we just want to do it like this, and we can pass it into the method. So this array will get copied into this variable. We may want to do an anonymous array if we don't want to change any of the values. If the anonymous array, if we pass it like we would with any method, a static value here, we can't change it. We can't do anything with it, right? Okay. So we talked about what an anonymous array, the syntax for that, the way that we create that is we give it the new keyword, whatever data type it is, string, int, whatever, bracket, curly braces with a bunch of stuff here, a bunch of information, all the different literals here, close curly brackets. Okay. There's no reference variable, so there's no way to point to it. So what happens is that after this method is over, this array just goes away. Okay, we just don't have any access to it anymore. All right. So now we go back to what we talked about, where we talked about the pass by value. And some of this stuff, I'm gonna let you look over this on your own. But I want to show you on the whiteboard for this because I think it's better maybe understood that way. But if we pass a value, a variable like x here, we pass its value into here. But we're saying that we're passing the array into here and not just the value. We're passing the reference. Well, but why does an array work that way and a simple variable doesn't? Well, let me pull up the whiteboard so you can see why it works that way. Okay. All right. So let's go back to all of this. Okay. So we talked about, I'm going to erase a few things that are unnecessary. I guess that was more necessary. Cancel. Okay. So we'll go back to this 0x1004, and we'll say it points here. Okay. So when we pass a variable into a method, we're saying take this thing here and pass it into the method. So we'll say this is my method. And this is terrible, my handwriting here. Okay, we'll pass it in there like that. But, and usually when we use variables here, we don't necessarily say that it points to a place in memory. The way we usually draw it is like this. We will say it's the sum variable, and it has a value of whatever 4. And so then 4 gets passed into my method. Okay. But when we pass an array, we don't pass all these values because that would be quite a lot, right? Especially if we have arrays of size 100. Like if I had an array that represented all the students in this class, all the students registered in this class, all 150 of you, that would be a large array to pass to my method, right? So what we pass is instead, we pass this here, this reference value. So what happens is when I pass into a method, let's say here, and inside of my method, maybe we'll have this variable called list. That's an array, an integer array, for example. And what'll happen is that list will get this value here, this 0x1004. Okay, so now what happens when I say, well, look in memory for whatever's at this value? Guess what? It sees this right there, doesn't it? And if I say, what's the next value after that? It sees this right here. And what's the next value after that? It sees this right here. Okay, so I'm pointing the address. I'm passing the address for the array into the memory. The variable, the array variable inside of the method gets the address so it can access these memory locations directly. And that's why we can change a value inside of a method if it exists inside of an array. Okay? So I hope that helps you understand that. Like I said, I would also encourage you to go ahead and look through these slides as well to kind of talk about the same thing, the reference variable versus the value, okay, to help you understand. But I think either one of those should help you understand why it is that we're able to change values inside of an array. Inside of a method, if the values are inside of an array, but we cannot change them for just individual values. Okay. All right. There's some other passing arrays. Okay, so we can pass arrays to a method. You know what else we can do? We can also return arrays from a method. Okay, so we might want to say, okay, I want to take this array and I want to reverse it, but I don't want to change the original array. I just want to send back the reverse version. Okay, so what would I do? I can create a new array that's the same size. For I equals j equals whatever, for I equals 0, so the first position in my new array, for first position in my old array, j is result.length minus 1, so the last index of my new array. I go through the entire array, adding 1 to I, subtracting 1 from j every time. And each time through, I take whatever is in the list, the past list from position whatever I is, and I put it in the equivalent opposite position in the result. So we'll trace through that in just a second, but what you'll see is that what is in position 0 of the original list gets put in the last position of the new list. What's in position 1 of the old list gets put in the second to last position, and so forth. And it keeps doing that over and over again until we've gone through the entire list. And then we take the result here, right, and we return it. Now notice again, we don't use the brackets. Don't put brackets here. Don't put brackets of, dot length or 0 or anything, because that would be individual values. What we want to return is we want to return that pointer to the actual array itself. We're returning the whole array, okay, after we've reversed it. So if we trace through and we see how this works, so we start with a list 1, 2, 3, 4, 5, 6. We create a new same size array, but notice they're all zeros. Remember, that's the default value. That's what the values start at. All right. So we've created our new array. Okay, I is 0, j is 5. I, 0, less than 6. Yep. So we copy what's in the list at position 0 into the result array at position 5. So here we copy this into there. Okay, so we add 1 to I, subtract 1 from j. 1 and 4. Still less than 6. So we take what's in position 1 of the old list, put it in position 4 of the new list. Copy it into there. Okay. Add 1 to I, subtract 1 from j, 2 and 3. It's less than 6. Hopefully you see kind of the trend that's starting to develop where this gets moved into here. Do it again. Now we get this into here. We do it at the end. This into there. Do it again. And we do 6 into 6. Now we're about to have this interesting situation, right? We filled up this result. What's going to happen? We add 1 to I, becomes 6. We subtract 1 from j, becomes -1. I is not less than 6, so we're done. Okay. Could we also have put in here, instead of I less than list.length, y, for the condition being j greater than or equal to 0? Absolutely. Right? Because notice that the two conditions that say we're done is either we've gone through the entire old list or we've added values to all of the result list. Either way. So either I has gotten so big that it's outside of the array, or j has gotten so small that it is outside of the array on this side. Either way, doesn't, farket mess. You can do it either way. Okay. So then finally we return the result. So we take the result that points to this array and we return it and we assign it to list 2. Okay. Here's some other examples. Now, when we're going to count the occurrence of each letter, it's an example of how we might search through an array for certain values. There's a couple of different ways that we can search through arrays. One is called the two basic searching algorithms that we'll talk about are linear search and binary search. I think this gets into binary search. Yeah, it does. Okay. These are more important for understanding algorithms and how fast algorithms can run. But basically, linear search says, I'm going to start at the first value. I'm going to keep going until I find the value or I go through the entire array. So notice here what we're going to do is we're going to go through the entire array. If I ever find the value that I'm looking for, so the key is the value I'm looking for. If the key equals whatever the list value is at the position I'm looking at, I'm going to return the index of that position. Okay? I'm going to say, take this index, return it. So when I return it, I say, this is where I found it. If you've ever used in Excel, the find function for finding in a string of characters, or Excel or Google Sheets, or there's also the find method in Java. These do that, right? They return the index of where that character or that string of characters is located. Okay. If we go through the entire array and we don't find our value, we return a -1. We're saying it's not there, so I'm going to return an index that I know is outside of the bounds. Okay. Linear search is what we would use. Linear search is what we would use if the array is all mixed up. Okay, there's no sequence to it, there's no ordering to it. It's just random. Okay, we're just trying to find, is our value somewhere in this array? Okay. Another searching, so if we look at this, we're looking for 3, We search the first item, it's not there. Next item, next, here. So then we would return 0, 1, 2, 3, 4, 5. So we would return the value of 5. Okay. Some other information about how you might go from the idea to the solution of this, right? Of how we might take, what are we trying to do? We're going to search through the whole array. So we need a for loop that searches through the array. If we find it, we want to do something. What happens if we get to the end of the array and we never found the value we were looking for? Okay, so here's some examples. Now, one thing that this method will do is it will always return the location of the first time it found it. So even if there's another time that that value appears, it won't return that. Okay. All right. Okay. Now, binary search is faster in general, but it requires that the array be ordered, be sorted. So it would require that either sorted lowest to highest or highest to lowest. Okay. And what happens is we search somewhere in the middle for our value. And if the value is lower than whatever is at the middle position, we go to the left. If the value is higher than whatever is at the middle position, we go to the right. That way we don't have to search every value in the array. Okay, hold on just a moment. Okay, sorry about that. I'm back now. What I was saying was that they needed to be sorted. So if you think about it, linear search is if you had a random group of, let's say, anything, words, students, whatever, and you were trying to find out if somebody was in there, if some word was in that group or whatever. So you would search through one by one to find it. Binary search would be more like you have a dictionary and you're trying to find the word computer. You wouldn't necessarily start at the very beginning and just go page by page. What you do, you might start in the middle and say, okay, what's in the middle? Oh, the L's are in the middle, so we need to go to the left. Okay, now we're at the F entries in the dictionary, right? So we need to go to the left. Oh, we're at the C's. Okay, now we're there. Yeah, now we're in the C's. Okay, now we keep going right and left depending on if it's greater than or less than what we're looking at. Okay, it's faster in general, but it is more complex as well, and that's usually the trade-off here. Okay, so binary search, like in a list like this, we're looking for the value 8. We say, okay, 4, is 8 greater than 4? Yes, so we move to the right. Okay, we look at 7, is 8 greater than 7? Yes, so we move to the right. Now we found 8. Okay, notice here, 2 comparisons, 2 wrong comparisons, and we get there. Had we done linear search, we would have had 1, 2, 3, 4, 5, 6 wrong comparisons, and then we would have gotten there. Okay. So that's how binary search works. We won't spend too much time today on this because this is more of something that you'll study in your algorithms class. Right. But in the same way that searching can have different ways of doing that. We can do linear search, we can do binary search. Sorting is also something that we may have a lot of different ways to do that. Okay? So you have selection sort, which is basically going through and finding the smallest value in the array and swapping it with the first position, right? And then going through from the second position on, finding the value that's the smallest in this portion of the array and swapping it with the second position. And then doing that over and over again until we end up with a sorted array. And these are all, I believe, given as examples. Yeah, this is all given as examples in the example folder, in the code examples folder that's on the class materials. Let's see. Okay, so I do want to. So we're going to finish up this set of slides on this. I do want to go ahead and go over that you have been actually writing an array since the very first piece of Java code that you've written. The very first main method included an array, right? You probably have noticed that this string bracket args. This is a string array, okay, that gets passed to the main method. And when the main method gets run, it uses this array as a parameter passed to it. Now, we can either call like a different class their main method with a string array of our own, or what this is mostly used for is for what's called command line parameters, command line arguments. So when we write a Java class and we go to run it, you guys have seen that we write Java and then the class name, and it looks for that main method and it runs it. But what if we wanted to pass some values to that main method? Well, we can do that through these command line arguments, right? That then get put into a string array. Okay, let me show you how this works. Okay, so in the calculator program here, we'll look at this example. Where are you? Let me share this code. Okay. All right. So let's see, calculator. That's the one I wanted to do. All right. Now, there's a couple of different ways we can do this. All right. One is if you're using an IDE, many of them have this where you can do this run argument. So what you would do is you do, let's see, build. Yep, there it is. Okay, so in JGrasp, what you do is you would click on build, you would click on run arguments, and then you can put them in here. Okay, so what we want to do is we want to do an example like, let's say 2 plus 3. Okay, let me actually make it bigger so you can see it better. Okay. All right, so we do this 2 plus 3. Let me put a breakpoint here. Okay. Now notice, okay. Notice here when it runs this, this Java keyword, and it runs the calculator class, it includes these on the end. Okay, it includes this as an argument on the end. Okay. Now what's going to happen is that it's going to look for these space characters, and it's going to say, okay, everything between the spaces, make it its own string. So 2 becomes a string, plus becomes a string, 3 becomes a string, and it makes a string array out of that and passes that to the main method. So if we look at args here, right, it's a string of size, it's a string array of size 3. First value is 2, second value is plus, third value is 3. Okay, so now the first thing it does is it checks, okay, so the calculator here, it's expecting some value, some mathematical operator, some other value. Okay, so now we step over that because that's true. So args.length, yep, it's 3, right? 3 values, so we're good. Okay, so now the result, just make it 0. Okay, so what's the operator? Well, we look into our array at position 1. What's the thing at position 1? It's this. It's, in our case, it's the plus sign. Right? But it's the whatever is the second position in the array. Okay. And what's the character at that 0? What's the character in the first position? It's a plus sign. Right? So we're going to say, okay, what is that? Okay. Case plus. Okay, yeah, that's what it is. So now we're going to take what's in the first position. We're going to try to get an integer out of it. We're going to take what's in the third position, or in this case, the last position. We're going to get an integer out of it, and we're going to add them together. Okay. All right. So now we're going to display the result. Args of 0, 2. Args of 1, plus args of 2, 3, but then we're going to display equals and whatever result is, 5. Okay. Let's go screen over. Yep. 2 plus 3 equals 5. Perfect. Right. Now there is a slight problem with this, and what we'll see is, okay, so what if we did like that and we try to run it? Now notice we don't have to recompile it. We're changing our inputs to it, but we don't have to recompile it. And that's really nice. So we can just run this. Okay. Now what's going to happen? Args is what size? Right. Args is what size? It's only 1. Why? Because it took this whole thing and made it a string. Right? So if we look at what the value is, it's the whole thing. So args.length is not going to be 3. So it's going to say, nope, bad, you can't do that. And we're done. Another thing that is interesting is, what if we did, let's see, that. Well, let's see what happens. Okay. Well, what's the size of args? It's 3, so that's good. All right, what are my 3 strings? 2, this thing, and 3. Okay. Well, what is args of 1 char at 0? Guess what? It's still plus, right? It's still going to give me this here. All right. So now, when I display the result, I get this. 2, blah, this all craziness, 3 equals 5. All right. So that's probably not what we intended to have, right? All right. Here's going to be another interesting thing. Let's see. Let me run it with 10 divided by 5. Okay. See, so args of 0, first character should be a slash, right? Yep. So we got down to here. I was expecting this would show me the double slash because in a string that's what it should be, but I guess not in here. Okay. So, yep, so 10 divided by 5. So this is a way that we can use that string array that's passed to a main method, right? That string array that's passed to a main method. Okay. Some other things that we talked about today. Let's see. We talked about the lotto numbers. So the idea is here, the way they do it is you enter information. The user will enter information. Let me do it this way. Let me compile it. And let me show you visually. That is covered array here. Okay, so notice that it's all 0 through 99. Sorry, 0 through 99, 0 through 98. Maybe 0 through 98 actually. Are you guys able to see this thing here with all the falses in there? I don't know if you can see it. Actually, let me do it this way. Come on. Okay, let me do it this way then. Let me share the whole screen. The desktop. Okay, so now you should be able to see this, right? Yeah, okay. All right, so now we have this is covered array. That's all these falses. And what we're going to say is, okay, enter the lotto number, because this is the idea that is if you're going through ticket by ticket. So let's say that I said, okay, the first number that appears is the number 6. Oh. 6. Oh. Oh, I guess jump that. Okay. Why are you not working? That is so weird. Why is it not doing this? Let me stop this. So I hit 6, enter. Now, what's going to happen is okay, it's not equal to 0. So we're saying, okay, I want to take what's in that 6th position. So it's representing 1 to 99. So 6 would be the 6th position in the array. So 1, 2, 3, 4, 5, 6, right? So position 5, that's why the -1 is there. And I'm just going to change it to true. And then I'm going to say, okay, give me another number that shows up on it. Right. So let's say 8 shows up. Okay. So we change that to true. And basically what happens is this is going to keep going as long as we're entering numbers on our different lottery tickets, on our lotto tickets. And if eventually we're going to run out of tickets and we're going to hit 0. Okay. We're going to say we're done. We've entered all of our tickets. And basically what's going to say is, okay, I'm going to go through the array. And I'm going to go through the entire array. And if something is not covered, if they didn't get a certain value in there, then I'm going to say, nope, none of them, they're not all covered. Okay? Because the only way that we can have all of them covered is if all 99 values are true. Yep. And we're done, because if we find one false, we've already discovered that we don't have all trues, right? We're not just checking the first value, Because if the first value is true, we still need to check the second. And if the second value is true, we still need to check the third, and so forth. The only way we know is if we hit one false along the way, that's done. We're all done. Okay. And we'll say, nope, tickets don't cover all the numbers. Sorry. Okay. Let's do a smaller example. Let's do, instead of 99, let's do a smaller number like 5. Let's say 5. And instead of that, let's say 5. Okay. So we can see how this works, okay? All right, now let's do this one. Okay, so now we have a 5-element array. We're going to say, okay, give me some value. Well, okay, 2 shows up. So then this one should become true. All right. Now 5 shows up. Okay, so that's true. Okay, 1 shows up. 3 shows up. Now let's say on a different ticket, because I don't know, I'm assuming many of you don't play the lottery, but in case you do, let's say on a different ticket, a same number from before shows up again. So 5 shows up again. You know, we don't have to check what the value is because we just need to always say it's true if it's there. So we don't have to change it. We just say it's always true if it's already covered. Okay, and then finally, not 3, 4. Okay, because I want to make them all true. So now they're all true, and we could keep entering more numbers. We could do 2, 3. You know, and we just keep doing that until we're done with all of our tickets. We say 0. It's done. Okay, now. Right now, we assume that we're all covered to start with. Now we're going to go through one by one through the entire array. We're going to say, okay, if it's not covered, which it's not covered, right? So is covered of I. So this is true. So not true is false. So we just skip over it. And we go and keep going. And we keep going until we hit a false value or until I is 5. And we hop out of the loop. Now, if they're all covered never got changed to false. It was true the whole time. Now, if all covered, we display, yep, tickets cover all the numbers. Okay. A couple of different ways that we use arrays here. One final example I want to go over, and we can actually call it a day a little bit early today. But one final example I did want to do is showing the passing of the array. Okay, so here, I'm going to do the canvas again because I want you to see what's inside of this thing. Okay. So I want to show you what's inside of here, what's inside of the A array that's in the main method. Okay. Before invoking the swap, the array is 1, 2. Now we're going to go inside of the swap method because this swap method takes a single integer value and 2 single integer values. Notice we don't pass the array itself. We're passing this value in the array and this value in the array. So if we follow along, N1 and N2, and temp. So temp gets the N1 value, N1 gets the old N2 value, N2 gets the old temp value. So we've swapped them inside of the method, but notice they didn't swap in the array. And the reason why was because, again, we passed the values of the array, not the array itself. Notice that the array has an address. That's that stuff I was showing you before. If I look back at this Microsoft Whiteboard thing here, this is that value, the address. That's what this is here, this object 297. That's saying that that's its address in memory. Okay. So here, when we come and use a different swap method, right, where we pass it, instead of passing individual array values, we pass it the array variable itself. Now what we're passing is this address. Notice 297. Remember that, 297, because watch what's going to happen. Oh, I skipped over instead of stepping in. Arrgh. Okay, I'm going to have to rerun it. Okay. Run it again. Okay, so now we're going to step into this array, okay, into this method. So I want to step in. What was the... Because now the address changed on me. Okay, I'll get this going correctly eventually. You just wait. You'll see. All right, let's go back one more time finally. Okay, all right. Array 299. All right, so remember that 299. Okay. So its address 299. We step in. Notice here, different name, same address, same object. So if I come over here, and it's like, okay, here's the array. Here is the A in the main method. Here's the array. Okay, notice object 299, a 2-integer array. Object 299, 2-integer array. All right, so now temp gets my old first array value, 1. Array of 0 gets the old array 1 value. Notice they both changed because they're both the same object in memory. They're both the same array in memory. Okay, now array 1 gets the temp value, which is the old array 0 value. So they are swapped now. So I step out, I print after invoking, now they are swapped. Right? And this is why, this is very powerful, because this is why we can change values inside the array if we pass the array to the method and not just individual values. Okay. All right. Okay, I think. All right. Yeah, I think that's all I really wanted to go over for today. So we finished off this the set of arrays slides here. Next week we will go over multi-dimensional arrays. So basically the idea here is I'll pull up the whiteboard so you can see here. If we see that this array points to this thing in memory that has a value in it. Okay. Well, what if we had an array in memory? Okay. Contiguous locations. And notice that here, I want to erase this here. So, okay. Okay. Okay, and this address points to this. Well, this is just a memory location in and of itself that just points to a certain position in memory. So what if each of these also pointed to another array? So what if this was an array of arrays? Okay. So it'd be like a spreadsheet or a grid, right? And that's what we'll talk about next week, is that we can do this in Java as well. We can have a multi-dimensional array. We can have this a two-dimensional array where instead of having just one column of values, we can have each of these represents its own column of values. So it'd be more like a row. So we can have a kind of a row column matrix type of thing. Okay, so that's a little introduction for what we'll talk about next week. If there are there any questions about what we've talked about this week? I'm sorry again for some of the technical difficulties on today's lesson. But if there are no questions for this week for the array stuff and passing them to methods and stuff, I hope I've cleared up everything about the assignment as well. The questions that were about the assignment. Somebody have a question? I saw a hand go up. Nope. Okay. Yeah. So if there are no questions, then we'll end there for today. A little bit early, and you guys can start looking at assignment 3. All right. Thank you guys very much. Have a good weekend. And again, sorry that we have to do lockdowns yet again. So hopefully this will be over soon now that the vaccine is coming. All right. Have a good weekend.